Swayam Prabha. Digital India. Educated India.
Namaste and welcome to this course on forest biometry. I am Dr. Ankur Avadia, an officer in the Indian Forest Service. In this course, we shall look at what forest biometry is all about, what we measure in this discipline, how do we measure those things in this discipline, why do we need this discipline, and so on. So, let us look at this term forest biometry and let us look at the word roots. So, we have forest biometry. So, this has three words in total. One is forest, the second is bio, and third is metry. The term forest is derived from the Latin word foris, which means outside. So, this is the same word root that we have in the case of foreign. So, foreign means an outside land. Why do we call forest as forest? Because in earlier times and also quite correct in today's situations, forests are outside of residential areas. So, they are not where people live. So, they are outside of villages, towns and cities. So, which is why we call these forests. Now, forests traditionally have been lands where you have a number of trees. So, this is a land that is covered with trees and also with some undergrowth. So, we could say forest is a tract of land covered with trees and undergrowth. In the case of our country, India, we have had a case called as the Godavarman case. Now, in this case, our Honorable Supreme Court has taken a dictionary meaning of forest. So, forest in India means two lands, one from the dictionary definition, so that is any tract of land that is covered with trees and undergrowth, or also any land that is declared to be forest under any act. So, for instance, if you went to Rajasthan and if you looked at the sand dunes there, you would be having vast expanses of land that do not have quite so many trees, but they might be having some undergrowth. Do we call these as forests? Yes, if they have been defined as forest under any act, or if they have been worked upon as forests traditionally, so we would call them as forests and we define them as scrub forests. So, that is what forest is about. The second term that we have in our definition is biometry. Now, biometry also is divided into two parts. So, here we have bio. Now, bio means something that is related to life. So, this is the same word root that comes in say biography, or in the case of biology, or in the case of say bioenergy, or say biogeography, or say biosynthesis. So, again looking at the word roots, bio plus graphene, graphe means to write. So, biography is the writing of a life, logy means study. So, biology is the study of life, bioenergy is that energy that is created out of life forms, biogeography is geography that deals with different life forms, biosynthesis is the generation or the synthesis of chemicals by various life forms. So, bio means life, something related to life. Now, the third point in this term is metry. Now, metry means to measure. So, where do we see this word metry? We see it in thermometer. Metron is to measure, thermo means temperature. So, it is something that measures temperature. We see it in geometry. Metry is to measure, geo means earth. So, the beginnings of the mathematical discipline of geometry related to the measurements of parts of earth. So, which is why we call it geometry. We see it in photometer. So, meter means something that measures, photo is light. So, photometer is something that measures light. So, now looking at it in toto, we have forest biometry. So, metry is measurement. So, what do we measure here? We measure something that is related to bio. So, we measure the life forms. Where do we measure it? We measure it in a forest. So, forest biometry is the science of measuring forests. Now, why do we need this discipline? Why do we need a separate discipline of forest biometry? We need it for a number of reasons. One, so let us call this reasons for this discipline. So, we have forest biometry. Why do we need this discipline? One, we need this discipline manage things. Now, why do we need to manage forests? Well, because why do we need forests in the first place? We need forests for a number of reasons. One, they give us wood. Wood is something that is needed by the society. We need it for the manufacturing of furniture, we need it for doors, we need it for a number of things. 1. 2. We might need forests to overcome climate change, because it is because when trees make wood, they are essentially converting carbon dioxide into biomass. So, that is leading to carbon sequestration. So, carbon sequestration is something that we need to bring down global warming. So, that could be another reason to have forests. We could also have forests just for the sake of having it, because it feels good to know that you have forests around. It feels good to go to a forest, you feel rejuvenated, you see a number of life forms. You could be managing forests for biodiversity, because there are so many species all around and they need forests to live. So, that is called as management by aims. So, you could be having the aim of gathering wood for your society, or to make a profit, or for carbon sequestration, or for biodiversity. You could also be managing a forest not for the wood for biodiversity, but for biodiversity per se. For instance, our national parks and the wildlife sanctuaries. So, this is where we are managing forests. But then why do we need to measure forests for this? Because you cannot manage anything till you know what you are managing, till you know how much of your quantity is there. only then can we tell whether that quantity is growing with time, whether that quantity is reducing with time, or whether that quantity is remaining constant with time. So, if we plotted Q versus T, now suppose you are managing your forest for biodiversity, you would want it to maintain in a position of status quo. If you wanted to manage a tract of land that is scrub forest, that is a denuded land, it does not have any forest, and if you wanted to manage it in such a way that it would have forest later on in future, you would go for this curve. Similarly, if you figured out that your forests were having this curve, you would think of reasons in which you could bring it to a steady state or to an increasing trend. So, for all of these purposes, you need to measure your forests. The second reason why we need this discipline is because of its predictive value. So, for instance, if we are making a plan, if we are making a plan to say mitigate climate change, and if we say that today we have a forest of say 10 million square kilometers, and after 5 years we will be having a forest of say 10.5 million square kilometers. So, would that change be substantial in our aim of mitigating climate change? How much of more carbon would it be able to sequester? If we wanted to know that, we would need a discipline with a predictive value. So, that would enable us to predict if in time t equal to T naught, if we had a biomass B is equal to B naught, and at time t equal to T when we want to know how much would the biomass be. So, which is why we need a discipline with a predictive value. Now, at what scale do we do these measurements? These scales could be at various levels. So, for instance, you could be measuring some trees that are growing in your backyard, or you could be measuring some trees that are growing in a farmland, because we are trying to promote agroforestry, so which is the application of forestry to agriculture and agriculture to forestry. So, it is a mixed bag in which in the same plot of land you can grow some trees and you can also harvest it for agricultural purposes. So, it becomes a dual use. So, suppose you want to popularize agroforestry, you would want to tell your farmers how much would their income be say after 5 years or say after 3 years. So, for those cases you would need to measure at a very small scale. So, if we look at the slide, we would see that we can have measurements at different scales. We can have local measurements or say even district level measurements. We could be having regional level measurements, say in the case of states. We could be having national level measurements, or we could even be having international level measurements, which might be important for planning purposes, say for climate change mitigation. Now, what is the time span in which we do these measurements? Now, as we talked before, we can have the time of present. So, for instance, if you have a tract with some trees, you want to know how much of wood is there, so you would be measuring it now. You could also be having a time span of future, which is used for predictive purposes. That is all about the time span of measurements. Now, what do we measure in forest biometry? If we looked at the slides, here you can see that on the left side you have a monument and right next to it is a tree. On the right panel you can see a few logs of wood. So, what can we measure using the science of forest biometry? In the case of a tree, you can measure a number of parameters, say the height of the tree, the canopy of the tree. So, canopy is the upper layer, it is the uppermost branches and leaves in a forest that often makes an umbrella over the bare ground. So, as we can see in this figure, you can measure the diameter of the canopy or the height of the canopy. You could also be measuring the diameter of the tree, or in the case of the logs, you could be measuring the diameter and length of the logs. from which you would be able to calculate the volume of the logs. You could be measuring the density of the wood. So, volume multiplied by density would give you the biomass. When you look up to the forest, you can see the canopy. So, here on the left panel we are seeing a forest from bottom up, and on the right side of the panel we are seeing a dense forest, a view from inside the forest. So, what do we measure here? Well, we can look at canopy closure. So, canopy closure will tell us what is the percentage of the view above that is covered by the canopies. So, suppose you had a canopy closure of around say 90%, or we could represent it as 0.9. So, that would mean that 90% of the light that is coming from top is being intercepted by the tree cover. So, only 10% of the light is able to reach down below to the ground level. On the other hand, suppose you had this canopy closure of say around 0.3, that would mean that if we draw these trees on the ground. So, suppose this, you have these two trees and you are trying to take a measurement at this point. So, from here you would see that only this much amount of space is available for light to penetrate, and all the other portions have been taken up by canopies. So, suppose if you had a canopy cover of say 30%. So, that would mean that 70% of light is available at ground and 30% is intercepted by canopy. So, why do we need this figure? Because if we had a canopy cover of 30%, so you have 70% of light that is available for your new growth. So, these are the locations that you could use for regenerating a forest. On the other hand, if you had a canopy cover of say 80%, so you have very little light. Now, plants need light to grow, they need it for the process of photosynthesis to generate new biomass. If your canopy was already very dense, you might not be able to grow new trees. At the same time, there are a number of species that are light demanding species. So, if you have a light demanding species and if you put it into the soil at an area where you have a very dense canopy cover, this species would die because it demands a large quantum of light. On the other hand, there are some trees known as shade tolerant trees. So, if you had a very good canopy cover and if you planted your shade tolerant trees, they would be able to thrive there. But if you planted them at a location that had very less canopy, they might die. So, all these measurements are required to manage your forest. Coming back to the slide, if we looked at the forest on the right panel, you have a stand. Now, a forest stand is a contiguous community of trees with similar attributes that distinguish it from adjacent communities. So, basically it is a patch of forest that has very similar attributes that are different from other patches. So, the stand has stand parameters. So, stand parameters includes your stand volume, carbon sequestration, biodiversity index and so on. So, the volume of the stand, the sum total of all the volumes of different trees of the stand would give you the stand volume. Carbon sequestration would be a measure of the amount of biomass that you have there in the stand. Biodiversity index would tell you how many different kinds of species are there in your stand. So, how do we measure all these parameters? So, we have a number of parameters. So, what are the various parameters that we have? We have diameter, as we have seen in both in the case of logs and in the case of trees. We have the girth, which is if you have a tree, the circumference of the tree would be the girth. So, you can also measure it for logs or for trees. You could also be measuring the basal area, which is the area of the cross section. You could be measuring height both for logs or for trees. You could be having a number of angular measurements, or let us call it just angles. You could be measuring mass. So, if you have mass in volume, you could be getting density. You could be measuring canopy, or you could be measuring other parameters. So, in this course we shall look at how do we measure all these and what are the standard ways of doing it, what are the instruments involved. So, if we looked at the slide again, so we have an instrument called calipers. So, you all have used vernier calipers in the schools. So, calipers can be used to measure diameters or lengths, but you could also be using a ruler or maybe a tape for the same measurement. So, which one do you use for what purposes? We also have an instrument called the wedge prism that you see in the central panel. So, it is a transparent piece of glass, and if you look through that wedge prism, as you can see here, it causes a displacement of whatever is in front of it. So, here you can see in the central figure that the central portion of the main stem is displaced towards the right. So, why do we need that? We will come to it in a later class. We also have altimeters, we have weighing balances for masses, we have clinometers for angles, we have range finders. So, these days laser range finders are a huge rage. So, we could use those to measure distances. We also have LIDAR. Now, LIDAR stands for light detection and ranging. So, this is one technique that uses laser lights to get a three-dimensional picture of your scene, as we can see in the slide. So, here we are seeing an aeroplane that is going above a ground surface. It is sending these waves and receiving those back, and then we are having a simulation that is showing us the topography of the place. We could be using a densiometer that is used for the measurement of canopies. We could also be using computer simulations. Now, in the first glance it might appear that this is a very primitive science, because it is very easy to measure these things. So, for instance, if we looked at this picture, here we are seeing a few trees, and suppose we wanted to measure the tree in the center. You would say that it is very easy, you would go there with a tape, or you would go there with calipers or with a ruler, and you would get the measurements. It appears easy, but the devil lies in the details. So, as we can observe in this picture, the tree is thicker near the ground, and as we go up the diameter reduces. So, to represent it in a figure, if you have any tree, the diameter, so suppose this is your tree, the diameter at the bottom would be greater than the diameters as you go up. So, suppose you had D1, D2, D3, D4, you would be having D1 is greater than D2 is greater than D3 is greater than D4. This is because of a thing that we call as taper. So, we will come to taper in a later class, but now coming back to the figure on the slide, here we can see that if you look at the very bottom of this tree, it appears thicker. If you go up, it becomes smaller. So, if you wanted to measure the diameter of this tree, where are you going to measure it? Which is the correct region to measure the diameter? And if you chose any particular region as your standard, would that be acceptable to others? There are a number of other complexities. So, for instance, if you looked at this site, it appears to be a very marshy or swampy location. How are you going to access this site? Especially if you wanted to take your calipers along, how are you going to access it? How do you take your instruments to this site? Even if you have taken your instruments, where do you stand? This tree appears sloping towards the left side. So, do you stand to the right of it, to the left of it, or where do you stand? Where do you measure the diameter? How do you deal with knots and branches? So, for instance, in this case you can see that this tree, as soon as if you move up from the bottom, you can see that you have a large branch that goes towards the left. So, how do you deal with these? So, suppose you wanted to measure the length of the main stem. Is the central stem the main stem, or is the left side stem is the main stem? Where does the canopy begin? So, when we talk about parameters, like let us draw a tree again. So, suppose this is your tree and this is your canopy. So, where does the canopy start? Does it begin here? Does it begin at, suppose you have a branch here, so is this your canopy? Or suppose you have a branch that goes like this, is this your canopy? So, suppose you wanted to measure the canopy parameters. So, canopy parameters include your canopy length, your canopy diameter, canopy height. So, how do you discern these values? Where does the height begin? To what height do we take the branch as a log? So, this is your tree. If you wanted to cut this tree, do you cut it till here? Do you cut it till here? Do you cut it till here? Because at all these different heights, you would be having a different diameter. How do you deal with forking? Now, forking is a situation in which you have a tree and it gives out branches like this. So, this is a forked tree. Now, if you wanted to measure the diameter of this tree, where would you measure this diameter? Is this one tree or is this two trees? How do you determine that? And where do you measure its diameter? Do you measure the diameter here? Do you measure the diameter here? Do you measure the diameter here? Or is your diameter the sum of d1 plus d2, or maybe the average of d1 and d2? So, how do you deal with these complexities? So, we have a number of complexities, and in this course we shall learn about these and several other topics. Thank you so much for your attention. Jai Hind.